Okay, so question number 4. Write plausible Lewis structures for A, formic acid, and B, acetyl aldehyde. Okay, so let's do formic acid first. Which is HCOOH. And to write out its Lewis structure, we first need to calculate the total number of valence electrons in this compound. So we know that carbon has 4 valence electrons, hydrogen has 1, and there are 2 hydrogen atoms, so we multiply this by 2. And oxygen contains 6. And again, since there are 2 oxygen atoms, we multiply that by 2. And we get a total number of electrons equal to 18. So now let's try to draw out our skeletal structure. So carbon is most likely our central atom. And I'm just going to draw single bonds to 2 oxygens and 1 of the hydrogens. And then I'm also going to make one of my oxygens bonded to the second hydrogen. So now I have this skeletal structure here. And if we look at the octet of carbon, it doesn't have a full octet yet. And there's only 3 bonds to the carbon. So since carbon prefers to have 4 bonds in total, I'm just going to make this top oxygen have a double bond. So now if I wanted to find out how many electrons I've drawn so far, I'm going to count how many bonds we have. So we have 5 bonds, and each of these bonds contains 2 bonding electrons. So I only have 10 out of the 18 electrons drawn so far. So for the remaining 8, I can place them as lone pairs on both of my oxygen atoms. Okay, so this is the Lewis structure for formic acid. And now let's do the same thing for acetyl aldehyde. Which is CH3CHO. Okay, so let's also start off by finding its total number of valence electrons. Carbons is 4. And we have 2 carbon atoms this time, so we multiply that by 2. Hydrogen is 1. Multiply that by 4. And oxygens is 6. So if we add all these electrons up, we also get 18 valence electrons. So now let's also try to draw its skeletal structure. We have the 2 carbons, and one of the carbons will be single bonded to 3 hydrogens, and the other one will be bonded to a hydrogen and another oxygen. So again, if we look at our second carbon, you can see that there is only 3 bonds to it, and carbon prefers to have 4. So I'm just going to make this a double bond. And if I count out how many electrons I've drawn so far, I have 7 bonds, so 14 electrons out of the 18. So for the remaining 4, I will place them on my oxygen. And this is the Lewis structure for acetyl aldehyde. So now let's see what the junior tutor said. Part A is to determine the total number of valence electrons for this molecule. So for carbon, there was 4, oxygen They showed the math and got 12 and 2, and when they added it up, they got 18. So this structure uses up 8 electrons, 2 electrons for each single bond of the 18 valence electrons. So this leaves 10 more electrons available. Place these 10 electrons as lone pairs on the oxygen atoms to complete the octet. So then they noticed that carbon doesn't have a complete octet yet, so they brought one of those pairs of electrons down to form a double bond between that carbon and the oxygen. Okay, so they got the same Lewis structure. And then for part B, they also got 18 electrons. And the skeletal structure doesn't seem to be showing up, but they still kind of explained correctly what the answer should be. So I'm just going to say this solution is correct. And then in brackets, there may be some issue in loading final answer.